have the freedom to move seamlessly back and forth through this computing continuum. I think in the process of doing this, we'll see a redefinition of the playing field between industries, between companies, breaking down barriers between industries that exist today, and expanding the boundaries of what's possible inside of computing. While Moore's law is very, very predictable, I think the continuum is not. The nature of the products that we enable are going to make possible are really limitless. For quite some time, what we've been focused on are things like speed, size, battery life. Those are still important. But increasingly, the differentiation is around things like bandwidth, user interfaces, social networking, and even tweets. 32 nanometers is here now. It makes it economically feasible for us to manufacture 1 billion plus transistor microprocessors in very high volume. 32 nanometer at Intel uses our second generation of high-K metal gate transistors. We've already reached yields on this technology that make it very production worthy and moving into high volume production. In fact, we've started production on the first microprocessor on this generation of technology, codenamed Westmere, for shipments to our customers in the fourth quarter of this year. Now, we're not stopping at 32. We've been working on a new technology, the next generation after 32, which is 22 nanometers. And I can't show you a picture of this transistor here because my guys just won't let me. However, I can show you, for the first time ever, the world's first working 22 nanometer silicon technology. Able to show you, it also works. It's the smallest SRAM cell ever invented. These transistors use a third generation of the high-K metal gate technology. Each SRAM chip has 2.9 billion transistors. Each array on the SRAM is 364 megabits. It's on track for production, second half 11, continuing our 2-year cadence. At Intel, Moore's law is alive and well. A number of years ago, where we bring in a new microarchitecture on an existing silicon technology, which we call a TOC, move to the TIC by shrinking to the next generation silicon technology, and then moving to a new microarchitecture, a shrink, and so forth. And we've done this for many, many generations in a row. This continues with this generation. I talked about 32 nanometers in the Westmere product, which has a new scalable architecture, a number of new features that we're very excited about, including one called Turbo that Sean and Dottie will discuss in their keynotes. But beginning with this generation, graphics has also now been integrated into the microprocessor. Looking forward to the next talk on 32 nanometers is Sandy Bridge, our next generation microarchitecture that will be out on cadence late next year. And looking forward into 22 nanometers, we already have significant design work on the processors that will take advantage of the silicon technology I just showed you on that width. But recently, we've introduced a second architecture that's not based upon the core products, but around Atom. And this is a microarchitecture focused on using our best technology, best silicon technology, to design the best products for internet-connected devices. And we now have the ability to deliver these devices on a predictable cadence, essentially generating roadmaps that you, our developers, can count on. You can see them here, 2-year cadence, a new core coming out about every 2 years on different silicon technology. The tick-tock cadence here is slightly different. What this really reflects is Intel's traditional pattern of innovation and integration. We'll use these new cores on successive generations of silicon technology to do proliferations of what we call SoCs, or system on chips. SoCs are a very big investment for Intel. We think that SoCs based upon the Atom core are what allows us to be able to move into all of the new markets that we'll be discussing in a few minutes. In addition to building these devices at Intel, we've also announced that we're porting this Atom core over to TSMC. And in doing so, we're rewriting the traditional rules of how Intel is operated. We're not doing this for capacity. We're doing this to be able to reach out to new customers, to allow customers who want to embed their own intellectual property onto an Atom Core SoC, or to use the wide variety of library devices, I/O devices that exist at TSMC to build semi-custom devices around Atom for themselves. New rules, new markets. When we looked at making the shift into doing SoCs at Intel, we had to rethink our silicon technology. At one end, we couldn't stop doing what we always had done, which is the next generation technology had to improve performance and had to improve leakage. And in fact, for our mainstream product line, we're delivering the same kind of fundamental increase in performance that we did between 65 and 45, also being delivered between 45 and 32 nanometers. We have the choice at the transistor level of, at the same power, increasing performance by 22%, or at the same performance, decreasing leakage by 10x. And we're delivering that kind of technology into the new products like Westmere that we've talked about. What we did differently with this technology, though, this generation, is stretch the curve. That orange line stretches down into spaces that we've never done before to be able to take advantage of the scaling capability of our silicon to build devices that have ultra-low power. In fact, the 32 nanometer generation of technology has a 30x reduction in leakage over its predecessor 45 nanometer technology. At the same time, we've got the new silicon technology for system on chip. We've also developed common libraries, common interconnect models to be able to really facilitate reuse and get SoCs out for a variety of market segments very, very rapidly. Growth driver for the industry. And in many ways, it's filled the gap in that Gartner slide. The netbook has been able to fill in the gap that would have ultimately, without it, had led to a down year, I think. I'm comparing here the first 6 quarters of shipments of the 3 hottest consumer electronics devices in the last 3 years. The iPhone, the Wii, and the netbook. And the netbook has outpaced all of these after the 3rd quarter, and there's really no looking back. So as we look at the opportunity around netbook volume and how to accelerate that even faster, one of the things that becomes very clear to us is that we need a better applications environment. These devices, as Art pointed out, are ultra portable. People want to do more on them than just running legacy applications. And increasingly, we're finding Atom is also at the heart of a lot of these other devices. So we have a common operating system strategy. What we need for this now is a common runtime strategy. And I'm very pleased to announce today that Adobe and Microsoft, there we go, Adobe and Microsoft are supporting both mobile and Windows with their runtime operating environments. And we expect to have, very shortly, similar level of support on Java FX. So you'll see Atom-based software environments continuing to flesh out in terms of multiple vendor support to allow you to do whatever you want on this. We also think we need a new developer program. Today we're announcing one. It's the Intel Atom Developer Program. And the focus here is to, we're aimed at developers and ISVs who want to create new or port existing programs over to Atom. We will develop and deliver tools and SDKs for this. We'll enable developers to be able to sell their components to other developers to be able to get a commercial arrangement going on there. And ultimately, I think we can drive much more innovative applications around Atom as a result of this. The first in the lineup is netbooks, but it's going to be followed by Atom-based handhelds and consumer electronics devices. An important piece in delivering this, I think, is an app store framework. Because users are increasingly comfortable in buying their applications from app stores, and many of our customers already host their own app stores and want to host more. So what we're working on is a framework to allow customers to do that. This is a mock-up of a storefront that a fictitious customer will be able to host using this framework. And today I'm very happy to announce that we have our first 3 customers committed to doing this. ASUS, Acer, and Dell. Let's just hear from a couple of those CEOs